In this video, we will talk about Newton's laws for rotational motion. Let's start with Newton's first law for rotational motion, which states that in the absence of external torques and with respect to an inertial frame of reference, an object either remains stationary or continues to move at a constant angular velocity. This law can mathematically be expressed as follows. Net torque sigma tau equals 0 implies that the angular velocity theta prime is equal to a constant which can be 0 or different from 0. Newton's second law for rotational motion states that with respect to an inertial frame of reference, the net torque acting on a system is equal to the product of its moment of inertia I and its angular acceleration theta double prime. So what is the moment of inertia? The moment of inertia, denoted by I or I delta, is a measure of the resistance of a system to angular acceleration about a given axis delta. In rotational motion, the moment of inertia is analogous to the mass in translational motion. Here are some examples of the moments of inertia about some specific axes of a particle and some solids, where m in the formulas is the mass of the system, r is the radius, and L is the length of the rod. In the International System of Units, m is expressed in kilograms, r and L in meters, and I in kilogram meters squared. Now let's work the following example. The angular velocity of a disk rotating about its normal axis is uniformly increased from 12 radians per second to 32 radians per second in a duration of 5.0 seconds by a constant net torque. Determine the value of the net torque, knowing that the disk has a mass of 10 kilograms and a radius of 0.30 meter. To determine the net torque sigma tau, we should apply Newton's second law for rotational motion, sigma tau equals I theta double prime. For this purpose, we start by finding the moment of inertia I of the disk with respect to its normal axis by writing its formula, I equals half mr squared. We replace m and r by their values and obtain I. The angular acceleration theta double prime is constant since the angular velocity is uniformly increased. Therefore, we can apply the formula theta double prime equals theta prime final minus theta prime initial all over the duration delta t. We plug in the values in the equation and obtain theta double prime. Now, by applying Newton's second law for rotational motion, sigma tau equals I theta double prime, and by replacing I and theta double prime by their obtained values, we get the net torque sigma tau equals 1.8 Newton meter. As for Newton's third law for rotational motion, it states that whenever an object applies a torque to a second object, the second one applies an equal and opposite torque to the first. And this is all for this video. Thank you for watching.